Alright, in today's video we're looking at an experiment that we use in grade 9 advanced science, as well as you could use this in a grade 11 chemistry course where you're studying stoichiometry. It's called the synthesis of zinc chloride. In grade 9 science, in the advanced program, we do a unit on elements and compounds. So in this experiment, we're going to synthesize a compound. We've already done an experiment where we decomposed a compound. Here we're synthesizing it, but we're also going to be quantitative. We're going to be making some careful measurements. So we're making the compound zinc chloride. To do that, I've got pieces of zinc metal, which are little squares of silver-colored metal, and I've got those in little cupcakes. We're going to record their masses in just a minute. We're going to react those things with hydrochloric acid. Hydrochloric acid is HCl. It's actually a gas at room temperature, and we call it hydrogen chloride, but when dissolved in water, we refer to it as hydrochloric acid. This solution is reasonably concentrated. If you're a grade 11 chemistry student, its concentration is 6.00 molarity, 6.00 moles per liter. If you're not a grade 11 chemistry student, its concentration is 0.219 grams per milliliter. For grade 9 science, we don't need to know the concentration of the acid, but if you're doing a stoichiometry experiment, you might want to write down one or both of those concentration units. So we're going to synthesize zinc chloride in this reaction. Grade 11 chemistry students, you can think about what type of reaction that would be. Zinc metal reacting with hydrochloric acid. You know one product is a zinc chloride, but there's going to be another product which a grade 11 student can already predict. So I'm going to take a weighing boat, put that on my balance and zero it. I'll take the first cupcake and I'm going to add the zinc metal pieces to the cupcake and to the weighing boat. You can record the mass of the zinc that you see there. So now I'm going to transfer that zinc to a test tube, and I'm going to use a Sharpie and I'm going to record the mass of the zinc on my test tube. Alright, so there's the first sample. We're going to do that again with 3 more samples. So here's the second sample of zinc. Record this mass on your data table. This is the mass of zinc that we're going to add to the hydrochloric acid. I'll transfer that to the second test tube. And now the third sample. Notice that the masses of the samples are similar, but they're not the same. Each sample of zinc is slightly different. So this time, again, record the mass that you're seeing on the balance. We'll transfer that to the third test tube. And then our last sample. And let's record that final mass. You know what, that one's very similar to another sample, so I'm just going to change that slightly. You can change your mass, so there, we'll use that one. So it's all 4 samples are different. So there's the mass of our 4th sample. There we go. I'm reading these numbers upside down, so I have to be a little careful to copy them down correctly. So there's the zinc pieces added to all 4 test tubes. Let me move the balance out of the way here. Now I've got some hydrochloric acid. This is 6 molar, as I said earlier. Okay, concentration 0.219 grams per milliliter. And I've measured out exactly 10 milliliters using a graduated cylinder. So this is 10.0 milliliters of the acid. You might want to record that if you're a grade 11 student. In grade 9 science, we don't need to know that number, the volume. I'm going to add that acid to the zinc pieces in the first test tube. Now I've already measured out hydrochloric acid in some beakers here, the same amount. So I'm going to put 10.0 milliliters of hydrochloric acid in each of the 4 test tubes. Now if you're looking carefully, you can see there's already a vigorous chemical reaction happening. There's evidence of reaction, there's bubbling occurring, If I feel the test tube, you can see the vigorous bubbles. A grade 11 student, you know what gas is being produced because you've already classified the chemical reaction. Grade 9 science, we don't really need to know the identity of the gas, but we're going to check it in just a moment. The test tubes are getting quite hot. Okay, so there's two evidences of chemical reaction, bubbling gas, and clearly it's getting hot, so that means this must be what type of reaction. If it's producing heat, there's a certain word that you would use to describe that. Now I'm going to collect some of this gas. I've got an empty test tube here. I'm going to collect some of the gas that's forming. It's going to rise up. This gas is less dense than air. So I'm collecting it in this test tube. I'm going to put the test tube upside down on a bench. I'll do that a couple of times. I've got 3 test tubes, but I think I'll just do it with 2. So I'm collecting the gas just for a few seconds. There we go. So I've got 2 test tubes of this unknown gas, and I'm going to take a match. Let's see if this works. If it works well. Grade 9 students, you'll recognize this test. I'm going to take a burning wooden splint and put it into the mouth of this test tube of gas, and we'll see if we get anything interesting happening. All right, so that was a characteristic result. Let's do it one more time. So here's the next gas. There we go. So I hope you were able to see that. I wonder if my hand was in the way. So I've got one more. I'm going to do that one more time. All right, so we'll collect that gas one more time, just for about 5 or 10 seconds. All right, so now that I've got the gas, we'll test that one last time. So a burning wooden splint is being put into the mouth of a test tube full of gas, and you heard and saw a characteristic popping explosion. So one more time. That one was not very impressive. There was a bit of flame there, but not that popping sound. In any case, so now that should give you evidence of the gas that's being produced, its identity. In grade 11 students, you would have predicted already the identity, but that test confirmed it. So that's the end of the first part of the experiment. I'm going to leave this to react overnight, and when we come back and the reaction's finished, we're going to do some further results with it. We're going to do some other calculations and some measurements. All right, so it's now day 2 of our synthesis of zinc chloride experiment, and I'm joined today by my teaching partner, Miss Watts, and we're going to conduct the second part of the experiment for you. Keep in mind that part of this experiment is aimed at just grade 9 advanced science students, while part of this is also going to be aimed at grade 11 chemistry students. So we've got here our test tubes that were left over the weekend, actually, and you can see that the chemical reaction has stopped. There's no more bubbling, and you might be able to see there's some pieces of zinc metal left at the bottom of the test tube. So if we have leftover zinc metal, remember we were reacting zinc metal with hydrochloric acid. If you're a grade 11 chemistry student, you would now know which of those 2 reactants was the excess reactant and which one was the limiting reagent. For a grade 9 science student, Ms. Watts, why is it important that we have leftover zinc metal today in terms of the procedure that we're about to do, a safety consideration?
So we want to make sure that all of the hydrochloric acid has reacted with the zinc metal. Otherwise, if we were to do our next step and evaporate, we might be evaporating some hydrochloric acid, which would be harmful for us to inhale.
Yeah, so if you had no more zinc left over today, then that would mean there is leftover hydrochloric acid. So then we would not be able to do this evaporation on our bench, but we could do that in the fume hood instead. The fume hood is where you'd evaporate if you thought there was hydrochloric acid vapor coming out possibly. So a grade 11 student, the hydrochloric acid was our limiting reagent. It got used up completely in the reaction. So what we're going to do today, we've got 4 evaporating dishes over 4 Bunsen burners. We're going to be decanting the zinc chloride solution. The zinc chloride is the product dissolved in the water. we're going to be decanting that into these dishes, but let's weigh the dishes first. So we'll weigh the dishes in the same order of our test tubes. So if you're watching the video, here's the evaporating dish for the first test tube. You want to record that mass. Our second test tube will use this evaporating dish. The evaporating dishes are similar, but they're not all the same. So you want to be sure you're recording the mass of each dish. This is the third test tube's dish, and now the fourth test tube will decant into this last evaporating dish. All right. So now we've got to take these test tubes and decant them into the dishes, but we don't want to get any of the zinc metal into the dish. So we're going to decant it, pour the liquid into the dish. We'll rinse it a couple of times with distilled water and add that also to the dish. And then we're going to put the leftover zinc metal onto some paper towel, and we'll weigh that at the end when it's dry. So I'm going to start with test tube 4 and 3 and Ms. Watts 1 and 2. So let's decant. You might be able to hear our neighboring teacher in the lab. A bit of a booming voice. So I'm going to add some distilled water. Because remember that the zinc chloride was dissolved in the water that was above the leftover zinc. We want to make sure all of the zinc chloride gets added to the dish. There's a few tiny little pieces of gray in my evaporating dish. So I'm getting a little tiny bit of excess zinc metal into the dish, and that's a source of error. Ideally, I would want only the zinc chloride and water to be poured into the dish. So you might note for yourself that there's a small amount of zinc metal which is being added to the dish. Now I've rinsed 2 or 3 times. Now I'm getting the leftover zinc onto my paper towel without without breaking my test tube. I'm going to stop trying to do that. I've got one piece which is stuck to the side. So I'm going to get a scoop afterwards and add that to my dish as well. All right, so there's my dish 4. Ms. Watts, you've got a little bit more zinc metal dust into her dish. And now I'm going to do the third test tube decanting.
I just realized to put that on 2 instead of 1.
Then we'll pour a little bit of distilled water, rinse with some distilled water, trying to get all of the zinc chloride, but none of the zinc metal into the dish. And one last rinsing with water. Now you don't want to use too much water. The more water you use when you're rinsing, the longer it will take to evaporate afterwards. But if you don't rinse enough, then you're going to be having some zinc chloride stay behind in the test tube, and that would be a source of error. So now I'll shake out that excess zinc, which came out nice and easy, onto its paper towel. So I just have to get this last piece of zinc out of this test tube onto my paper towel, and Ms. Watts, you've got yours ready to go there. So why don't we pause the video just for a moment. I'll get this out, and then we'll light our burners and we'll get this evaporating.
Sounds good.
All right, so we've got the leftover zinc on paper towel drying right now, and we're ready to start evaporating. So Ms. Watts is going to light her burners. I'll get the second one here. And now, okay. That one's not wanting to light, but we'll just let it go for a moment. So we'll light another match. Give that a try.
Nope.
All right, so we got to get another burner, but let's get these guys lit as well. There you go. And this guy here as well. So now we're going to evaporate the solutions to dryness, and then we'll let them cool when they're done. And we'll show you what that looks like before we continue.
Okay, so here we are. We have had our burners running for a little while now. The two burners closest to myself are a little further along than the other two. We can start to see some solids starting to precipitate in our evaporating dish number 1 over here. The other two are a little bit further behind.
All right, so we've got 3 of our dishes probably finished. These 2 definitely finished. This is the zinc chloride powder after we have evaporated it, after we evaporated the water. Okay. I think that one's probably done, Ms. Watts. Zinc chloride has a relatively low melting point, so as we heat, when the water is finished evaporating, the zinc chloride would actually melt. So during the heating, you'll start to see it turn white crusty, and hopefully you'll see some of that here. That's the zinc chloride salt. But then as we continue heating, that white crusty zinc chloride salt will begin to melt. So what happens is it goes from looking wet when there's lots of water to looking drier and drier when there's less and less water. And then it actually starts looking wet again because the zinc chloride is beginning to melt. I'll show you that here in the video. So there's the white solid zinc chloride. And there's still, I think, a little bit of water left in that dish. So I'm going to continue heating. I'm going to heat until I start to see it turn wet again. Okay, you can see in the video some white, puffy looking solid. That's the zinc chloride. Maybe there was still a little bit of water left in yours too, eh, Ms. Watts?
So, yeah.
I think I can see that white, puffy solid still. And then we'll start to turn dry. This one's now looking pretty dry. So at some point soon, I'm going to start to see a little bit of wet around the edges. I think I'm seeing it already. That means that white solid zinc chloride is actually starting to melt. So this is our third dish. It's now finished. And Ms. Watts is just heating the 4th dish there to dryness. For some reason, the zinc chloride in that 4th dish is a little bit discolored, isn't it?
It is, yes.
It's not its white color. It's got a bit of a brownish impurity. I don't think that'll affect our results, but you might want to note that if you're watching this from home. So we're going to finish evaporating. We're going to let the dishes cool back down to room temperature, and then we'll record some more masses.
Okay, so now we have cooled our dishes and we're ready to take the mass of the dish plus the zinc chloride salt. It was important that we waited for the dishes to be cool so that we don't damage the balance when we place the dishes on it.
Now, if you're a grade 11 chemistry student watching this video, you're able to actually predict based on the amount of hydrochloric acid that we used, our limiting reagent. You should be able to predict what mass of zinc chloride we should have produced in the experiment. So as you see us record these masses, you're going to have the actual yield of zinc chloride for each of these 4 experiments. You could calculate the theoretical yield doing a stoichiometry calculation, and then the percent yield for each experiment. So let's weigh the first dish.
So this was from test tube number 1.
You can see the solid zinc chloride in that dish. So this is the mass of the evaporating dish with the zinc chloride salt produced. The second dish, the salt looks a little bit different. It's probably melted and turned liquid and then solidified again, but we know from the law of conservation of mass that melting would not affect the mass. So there's the mass of the second dish with its zinc chloride. The third dish with its zinc chloride solid. Now keep in mind that if we didn't heat long enough, then there would still be water present in the dishes, and that would mean our mass of zinc chloride would have been too high because we'd be measuring some water as well. But we're pretty sure we heated these all to dryness. So there's the 4th dish with its mass of zinc chloride inside. Now, for grade 9 students, we need to do one last thing. We need to know how many grams of zinc metal did not react. We need to know how much was the zinc metal's mass that's left over today. So I'm going to put a weighing boat and I'll zero that on my balance. So let's begin with test tube 1. So you recorded at the beginning the mass of zinc that we added to the test tube. Here's the mass of zinc that's left over at the end of the experiment. So using those two masses, you could calculate the mass of zinc that reacted in the experiment. All right, so now test tube 2, let me discard that and I'll re-zero the balance. Test tube 2, here's its zinc. Now again, the zinc was initially wet, but it's been sitting on paper towel and we're pretty sure it's dry. But if it were a little bit wet, that would also be a source of error. So there's the leftover zinc from test tube number 2. And now test tube number 3, we'll zero the balance again with the weighing boat. And here's the leftover zinc pieces from test tube number 3. That's it. So again, record the mass, and then you're going to be able to calculate the mass of zinc that reacted in the experiment. And here's our test tube number 4, the leftover zinc. So if you're a grade 9 student watching the video, you now have enough information to calculate two things. You can calculate the mass of zinc that reacted in each of the 4 situations. You can also calculate the mass of zinc chloride that was produced. And because the zinc that reacted ended up in the zinc chloride produced, you could now calculate the percentage of zinc in the zinc chloride's product. You would take the mass of zinc that reacted and divide by the mass of zinc chloride that was produced and multiply by 100 to get a percent. This will lead to an important law, the law of constant proportions, which we'll talk about again in another video. So a grade 9 student, go ahead and use the information here to calculate the percentage of zinc that was in the zinc chloride in each of the 4 test tubes. Hope you've enjoyed this, another lab video for grade 9 science.